Hi everyone, welcome back to the channel. Today we are going to go over chemistry higher tier, and this is for GCSE peers and Edexcel. This is the predicted paper 1 for 2024. Make sure you like and subscribe. We'll be going over all of paper 2 predicted paper, and we'll also start putting out videos for every possible exam question for every topic for chemistry and biology. Let's get started. Question 1. Figure 13 shows a model of how particles are arranged in a solid. State 2 ways in which this model fails to accurately represent a crystal of sodium chloride. So if we look at the figure, we can directly see that even though that there is 2 different elements, sodium and chloride, we can see here that first of all, they're all in the same color and it's all in the same size. That is the first limitation. We can say particles are the same size when they should be in different sizes. We also know that everything that we see, it is in 3D. There's nothing that is in 2D because this is a real life object. So we can say that this model is represented in 2D. However, in real life, a crystal is in 3D. Magnesium oxide has a melting point of 2,852 Celsius. Explain why magnesium oxide has such a high melting point. Now, these are the same 3 things over and over again, so make sure that you learn them, because every time you see something on why something has a high melting point, it is these 3 things over here. So we know that magnesium oxide, because it is a metal bonded by a gas and bonded by a non-metal, we know that this is ionic bonding. So what we can say that there is very strong bonds. This is because they are ionically bonded. This is between 2 cations, which are positive. You can say it as cation. Cats are something that are nice, it's positive, and 2 minus of anions. So we can say anions, kind of like onions, they are negative, they make you cry. And the last point that ties this to the question is that this means it requires lots of energy to separate magnesium and oxide ions to melt the solids. So when we talk about energy, we know that this means heat, because heat gives energy. Bi, carbon dioxide can be formed by a reaction of calcium carbonate with dilute hydrochloric acid. So write the balance equation for this reaction. So we'll just start with writing what we know. We know that it is calcium carbonate, so we'll start with there. We know that this is reacting with dilute hydrochloric acid. We know that this is the equation. So what do this form? We know CO2 forms. This is what we know so far. So we have some other elements that are left over here. We need to make sure that we add them. So we have 1 oxygen left. If we take CO2 out, we have a carbonate and we have HCl. So what we can do, we know that calcium chloride will be formed, and we also know water will be formed. Now all we have to do is balance this, and how we balance it is that you can see over here that there's 2 Cl's. However, here we know that there is only 1, so we can just put a 2 over here. Therefore, this is the answer. 2I, the thermal decomposition of copper forms a copper oxide and carbon dioxide. 15 grams of pure copper carbonate is decomposed completely. Calculate the mass of the solid produced, and its C is 12, O 16, and Cu is 63.5, and give your answer to 2 significant figures. This is really important. Lots of people end up forgetting this. That means losing a mark. So what we can start is the equation that we are going to use is that moles equal grams over mR. We're going to start by finding the formula mass of copper carbonate, which is over here. So how we do this is just we add all of this. We have 1 copper, so 63.5. We have 1 carbon, so that's 12. We have 3 oxygens, so that's 16 plus 16 plus 16. We know that that equals 123.5. And now what is it for copper oxide, which is because they only want calculate the mass of the solid produced, so they don't want this, as you can see, because it is gas. We only want the solid, which is only copper oxide. So if you find the relative formula mass of copper oxide, that is 1 copper, so 63.5, and 1 oxygen, so plus 16, that is 79.5. So what we need to do is we need to find the mass of copper oxide. So what we do is that all we have to do is we know that it's over here. We do 15 times 79.5. We divide this by 123.5, and it's 9.7. C. Magnesium reacts with water in the form of steam as shown in the equation. 2.4 grams of magnesium reacts with sufficient steam to complete the reaction to form 5.8 of magnesium hydroxide and 0.2 grams of hydrogen. Show by calculation by the law of conversion of the mass applies in this reaction. So how we do this is first we are going to find moles. How do we find moles? It's this equation that we've put over here. It's N equals grams over mR. So let's find this for magnesium. We know that it's 22.4 grams. And what is the mR? We can see over here the mR is 24. So we know that the moles is 0.1, and this is for magnesium. So how many do we know? We know if 0.1 mole is magnesium, we just need to now see ratio because it's 1 to 2. We know that it's 0.2 magnesium over here, and we know that these are just 0.1 because there's no number in front, so it is a 1-to-1 ratio. So we want to see how many grams of water. We do this by just rearranging this, so it will be N times mR will equal grams. We'll use this now for water, so we know it's 0.2 moles, and we times that by the atomic mass, so we know there's 2 hydrogens, so it's 1 plus 1 and plus 1 oxygen, so plus 16, and if we do that we would get 3.6 grams. So we know that we want to see now how many overall, what the mass of reactants is, so we know it's 2.4 grams of magnesium, and we also know that it is 3.6 grams of water, so we can see that this is overall 6. Now what is the overall mass of products, so that we can see if the law of conversion applies? We can see that it is 5.8 plus 0.2, which is also 6. Therefore it applies because it just means that the mass of the reactants are always going to be the same as the products. Two, the position of 5 elements A, B, C, D is shown in the periodic table, and these letters are not atomic symbols of these elements. So use elements A, B, C, D, E to answer I and 2I. Give all the elements that are metallic. So we know, if you see over here, when it comes to this area here, you just need to remember this. All of this over here are considered non-metals, and everything here are considered metals, because this part over here are actually also called the transitional elements, which are all metals. So we know that it is A, B, and C. Give the letters of 2 elements that have the most similar chemical properties. When we are talking about chemical properties, we talk about electrons. And the exact type of electrons that we are talking about, we're talking about the electrons in the outer shell, because the electrons in the outer shell are the ones that determine how the reactivity is, their chemical properties. So we know that in a group, every single element that goes down a group has the same number of electrons in their outer shell. So group 1 all has 1 electrons in their outer shell. So we know now that group 2, all of this, so A and B both have 2 electrons in their outer shell, meaning it is both A and B that has the most similar chemical properties. An atom of element B contains more protons than atom of element A. State how many more protons there are in atom of element B than element A. We know that the modern periodic table, this is arranged by proton numbers. So we can easily know that this is 1, 2, do it in blue, 3, 4, 5, 6, 7, and etc. So we just need to see what is the difference between these two. So you can just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is over here. Oh, here. An atom of element E has the atomic number of 10 and the mass number of 22. How many electrons does this atom contain? So atomic number means proton and mass number is proton plus neutron. And in a neutral atom, in a neutral element, we know that proton is the same number as electron. So because we know that the atomic number is 10, and that means proton number, we know that electron is also 10. 2i, 10% of the atoms in sample of element E has a mass number of 22. All the other atoms in the sample of the mass number of 20. Calculate the relative atomic mass of element E. So we already know that all the others just means 90%, because we just do 100 minus 10 from over here. So we are going to start by, we do 10% times 22. So we do 22 times by 10. And we add this also by the other one, so we know it's 90 times by 20. And what we do is that we just divide all of this by 100. And that is how you find a relative atomic mass. You do the isotope times the percentage, and you add this by all the different isotopes they have, and you just overall, you divide it by 100. So if we do this into a calculator, we will get the answer, which is 20.2. D. Element below E in the periodic table is used to fill filament's light bulb. Explain why this element is so suitable for use. So if you see element E, we know that it is over here, so it is in group 0. If it's below, it would mean that it's over here, which means it's also in the same group. And because it's in group 0, we know that it is a noble gas. A noble gas is inert, which basically means that it does not react. It cannot react, and this is because it has a full outer shell. All of it is 8. And as I said before, it is the outer shell that determines what is reacting and their reactant and chemical properties. So because it's outer shell, it doesn't have any electrons so that it can share with someone else or can give to someone else. Therefore, it cannot react, which means that it prevents the filament from reacting. 3. Sulfur trioxide is produced by reacting sulfur dioxide with oxygen. The reaction takes place in an industry of 12 atm pressure and can reach a dynamic equilibrium. Just seeing this here just means that it is a reversible reaction, therefore it will always reach equilibrium. So explain the effect of the rate of attainment of equilibrium if the process is carried out at pressure higher. So over here, they only want us to talk about the rate at which they go into equilibrium. So if you see 2, you would always, in a graph, if we put this into a graph, we'll say that these are the 2 products. We have these 2 products over here. We have one, and this is the second. And this over here is exactly when they reach equilibrium, and this is where the concentration is exactly the same. So when it says the rate, it just means, does it come faster? So is it just in a less amount of time, or does it go less? So we know because pressure increase, this is the same as any normal reaction, whether it's in an equilibrium or not. We know that the rate of time to reach equilibrium will definitely be reduced. This is because the gas molecules are much closer, it's much more concentrated, there is more of them. So this increases the collision rate, meaning there's more frequent collisions between these 2 particles, between sulfur dioxide and oxygen. Therefore, they're more likely to meet, so they're more likely to actually initiate a reaction. What volume of oxygen in centimeter cube will react completely with 500 of sulfuric dioxide? And we know that this is A. B. When there are alternative methods of producing a product, the final pathway is chosen by considering atom economy, cost of energy, yield of product, and rates of reaction. State another factor that should also be considered. So because we know that when we do it, it doesn't always mean that we're going to get one product. Sometimes we get the product that we desire, and we have waste products, which is here atom economy. So we can see what the usefulness of the byproduct is. The more useful it is, the more we might want to do it, because we get this other product that we can also generate income from. And we can also do equilibrium position. If you see over here, which way do you want it? If it's more to the left, meaning that it will produce more of these, or if it's more to the right, meaning it produces more of this product, which product do you desire more? C. The reaction between nitrogen and hydrogen is exothermic, and if nitrogen and hydrogen reacted at 150 atmosphere pressure and 300 CSCS without a catalyst, only some ammonia would be formed. In Haber process, pressure of 150 atmosphere and temperature of 450 are used in the presence of an iron catalyst. Explain why the conditions used in the Haber process are better for the first set of conditions for the manufacture of ammonia. So when you talk about why is it better, why do you prefer it, evaluate, we are always talking about two things. We always want to know rate. How does this affect rate? Because the faster it is, the better it is for us, because we don't waste as much time. We can make much more products and make much more money in the same amount of time it would take to make something else. And we're also talking about yield, which is basically the amount of product that we make from the things that we want. So if we talk about temperature, we can see over here that we increase the temperature. The second one with the iron catalyst increase the temperature. How does that affect it? So we know that higher temperature reaches equilibrium faster because molecules move faster, basic kinetic. And therefore there are more frequent collisions because the molecules have more collisions. And because there's this more collision, they more have the required energy. Therefore there is more and more of this reaction actually happening. But the yield will be lower. And why does the yield be lower? We know that this is a exothermic reaction. And because this is an exothermic reaction, because when we increase higher temperature, it favors endothermic. That is always. So higher temperature always favors an endothermic reaction, whichever side that is, they will always tell you in a question. And if you decrease temperature, it will favor the exothermic side. And so the equilibrium here will shift to the left-hand side. So it'll go back this way because we know the forward reaction is exo, meaning the other way, the backward reaction has to be an endothermic reaction. This means that we decrease the yield because what we are looking for this ammonia over here. This is the decomposition of ammonia. Now we talk about the catalyst because over here, this is something that's different between these two. It is the iron catalyst. A catalyst is always going to cause a reaction to reach the equilibrium faster. This is because it lowers the activation energy, but it does not affect yield. A catalyst never affects yield. All it ever does is just makes it reach equilibrium faster, and it does not affect the position of the equilibrium. Now, one other thing that we usually need to worry about is pressure over here. However, pressure is the same in both reactions, so therefore it does not make a difference and isn't a deciding factor on why something's better than the other. Question 4. Which of the following pairs of substances contains one substance that is soluble in water and one that is insoluble in water? Put a cross in the box next to your answer. So it is the first one. We know that aluminium nitrate and lead sulfate. B. Barium chloride is an ionic compound and has a high melting point. Explain why barium chloride has a high melting point. This is again the same as the first question. Because we know it's barium and chloride, we know that this is ionic bonding because it is a non-metal bonded with a metal. So we know that there is strong electrostatic attraction. Electrostatic basically just means it's a positive and it is attracted with a negative, so electrostatic. And this is between oppositely charged ions over here, so it requires a lot of energy to overcome these forces and to be able to actually break these bonds. C. Barium chloride solution is used to test the presence of sulfate ions in the solution. When sulfate ions are present, insoluble barium sulfate is formed. Describe the appearance of this, and it is that it is a white precipitate. Complete the balance equation for the reaction between barium chloride and potassium sulfate. So we can see that we have these two. Because barium is more reactive than potassium, this is going to displace it. So we know it's BaSO4, and we just kind of combine the other two that are together. So it's 2KCl. Compound X is a metal carbonate. A flame test was carried out on compound X and a lilac flame was seen. Complete the sentence by putting a cross in the box next to your answer. The formula of the metal ion in compound X is, we know that this is potassium because potassium shows a lilac flame. 2i. Lead carbonate is an insoluble salt. Describe how a pure dry sample of solid lead carbonate can be obtained from sodium carbonate solution and lead nitrate solution. With these type of questions where it's about getting a pure dry sample, which is basically a salt, trying to get salt out of it, it is the same 4 things, it is the 4 methods that you just need to learn. So number 1, it's to add, mix, or react only sodium carbonate with the lead nitrate, both of them solution. And then once you do it, precipitate will be formed. So then what you do is you filtrate that precipitate off. And then once you do that, you wash and rinse it so that any solid or residue, and this is with distilled water, and you dry either using a filter paper or paper towel, or you can dry it in a warm oven. And this is how the salt is formed. Question 5. A solution of copper sulfate in a beaker is electrolyzed using copper electrodes. Draw a labeled diagram to show how this experiment would be set up, and a beaker has been drawn for you. So over here you can see that we have drawn, these are the electrodes. These are all made out of copper. And then we have a positive and a negative. And this is always going to be connected to a battery supply over here, which is labeled. They specifically said that we need to label, so make sure you label all of them. And then you can see over here that this is put in a solution, which is the copper sulfate solution. 2i. During electrolysis, the anode gets smaller and the cathode gets larger, and the solution remains the same shade of blue. Give a reason for each of these observations. Number 1, the anodes get smaller. Why it gets smaller is basically because the copper atoms form ions, and when they form ions, it goes back into the solution because ions are they're soluble in the solution, so it goes back into it, therefore it gets smaller and it decomposes it. Why the cathode gets larger, this is because the copper atoms are formed, and this is from the solution and it becomes solid, and this is the reduction of the copper ions, and the solution remains the same shade of blue because overall the net, it's the same number of ions that enter and leave the solution. Question 6. Objects made from transition metal are sometimes coated with a thin layer of another transition metal to improve their appearance and protect against corrosion. So a figure 10, show an equipment that can be used to electroplate an iron spoon with silver. Which rod table correctly shows the charge of a silver rod electrode and the type of reaction that's occurring in this electrode? So we can see that it is positive, so we know it's one of these. And what is occurring in this is oxidation. So it's C. 2i. Silver metal is deposited on the spoon. What is the half equation that represents this reaction? This also is C. B. The voltage of a cell is 1.5 voltage. Give a reason why this voltage of the cell decreases when the cell is left connected in a circuit. The reason why is because the reactants are being used up. C. Duralumin is an alloy of aluminium and copper, and the radii of aluminium copper atoms are shown in figure 11. We can see that they're both different. So explain why copper is added to aluminium to form the alloy and what makes the alloy stronger than pure aluminium. So if it was just pure aluminium, since they are all the same size, you kind of just be arranged something like this, which means that it can just easily slide off because there's nothing that's actually keeping them apart. They would just be all in layers. So because they have aluminium and copper have different size atoms, this prevents the layers of the metal atoms from sliding over one another. So it kind of end up looking something like this. So if you have this is the aluminiums and we have this over here, we can see that it's less likely to slide over each other and it's more fixed in position, and that's why it's so much stronger. D. Gold is often alloyed with other metals when it's used to make jewelry. The proportion of gold in a piece of jewelry is measured in carats, and pure gold is 24 carats. A 9-carat gold ring has a mass of 12 grams. Calculate the mass of gold in this ring. We want to start by seeing what portion of gold is actually in it. So we know it's 9 carats, and pure gold over here is 24. So we do 9 divided by 24, and this is 0.375. And we know that this overall has a mass of 12 grams. We want to see how many grams of gold. We know this is the percentage of gold there is, so we'll just do 12 times 0.375. and it will come out to 4.5. So there is 4.5 grams of massive gold ring. Question 7. In the 19th centuries, Mendeleev arranged the elements known at the time to form his periodic table. Mendeleev periodic table is different from the modern periodic table. State one difference between the Mendeleev periodic table and the modern periodic table. One difference is that when Mendeleev did his periodic table, this was arranged by atomic mass. However, in modern times, it is arranged by atomic number, which is basically proton number. Also, another one is that in Mendeleev's early periodic table, there was a lot of gaps and missing elements and fewer elements. This is because the noble gases weren't present at that time, and he knew that when it does get discovered, he'll put it in there. So there's lots of gaps. However, right now we think we discovered most of them, so we don't leave any gaps. 8. Hydrogen and oxygen fuel cell can be used to provide electrical energy in spacecraft. The reaction that takes place in fuel cell is hydrogen plus oxygen water. Evaluate the advantages and the disadvantage of providing electrical energy in the spacecraft using hydrogen oxygen fuel cells rather than chemical cells. So we need to make sure that we are talking about it being in a spacecraft. There's a lot of different advantages and disadvantages. Because this is 6 marks, I recommend you do 3 advantages and 3 disadvantages, or if you do favor one side and you do think of more for the other, you can do 4 and 2, that kind of ratio. I do recommend that you just write as many reasons as possible, and then in your conclusions at the end, it doesn't matter which side you end up taking, you won't score any marks, as long as you give your reasons very clearly on why you chose that for a reason. So here are some advantages you can say. So you could say for advantages, once set up, fuel cells require no maintenance. However, chemical cells will need to be replaced, and chemical cells have a limited lifetime. Fuel cells can also operate as long as the reactants are supplied. However, voltage drops in chemical cells as reactants are used up. And once used, chemical cells cannot be reused again, and they do need recharging. And used chemical cells take up lots of valuable space on the spacecraft, while new chemical cells need to be transported to the spacecraft, which can be very expensive. And also, water produced in fuel cells is the only products, and this is actually pretty good because we can find a usefulness for this, because water can be used on the spacecraft as drinking water. However, some disadvantage of using fuel cells is that hydrogen and oxygen must be supplied, and gas tanks needs to be transported by the spacecraft, and storage of hydrogen is very difficult. This is because it's a gas and it's also flammable. And fuel cells are also very expensive to manufacture. Question 9. Nitrogen and oxygen are present in the air. A. In the industry, nitrogen and oxygen are obtained from the air. Give the names of the process used, and this is fractional distillation. This is how we separate them from the air. 2. State why the air is cooled before you start the process. This is so that you can make it liquid, because with fractional distillation, all of it has to be liquid so that we can separate it, and this is based on boiling points. B. Complete the sentence by putting a cross X in the box next to your answer. Oxygen has a low boiling point because there are weak forces of attraction between these oxygen molecules. There means it doesn't need much energy, therefore not much heat, so that you can actually break these weak forces of attraction. Another gas present in the air is carbon dioxide. There are covalent bonds between the atoms in the molecule of carbon dioxide. Describe what is meant by this covalent bond. This is a key term definition. I do really recommend that you learn it, as well as all the other key term definition. There is a shared pair of electrons between atoms. So you get 1 mark for shared pair, and this is between electrons between atoms. The electronic configuration for oxygen, atomic number 8, is 2.6. Give the electronic configuration of carbon, where the atomic number is 6. We know that when it comes to drawing outer shells, we know that the first one can only get 2, while the second one can get 8. So this is how a full one looks like. So we know that atomic number is 6. So that means it has 6 electrons. So let's draw it out. So we have 2. That means we have 4 left over. So it kind of looks something like this. So how you write it is that you basically say 2 in the first one, and then there's 4 in the next one. 3I, draw a dot and cross diagram of a molecule of carbon dioxide and show outer electrons only. How this works is because it's two non-metals going together, we know that they are covalently bonded, as we said before, so they are sharing electrons. So let's start with the carbon. We do the carbon in the middle, which is over here. We only show outer electrons, so we already established that there is 4. So let's put it as 1, 2, 3, and 4. And we know it's dioxide, so there's 2. So we'll put 1 on either side. So we'll do here and here. So we have oxygen over here and oxygen over here. We see over here that there is 6 on the outside. So we'll do 1, 2. 1, 2. We'll do this in a different color. We do 1, 2, 3, 4. Now we do 6. 6 over here will be together. So you can see over here that it is 2. They share 2 pairs of electrons. So 2 pairs of electrons shared between it. This is because when you're trying to share them together, you want every single electron to end up having 8 electrons in its outer shell. This means that it completely reacted. So over here you can see that right now oxygen is completely half. So if you now do it on the other side, it will be the exact same way. Now we have oxygen has 8 electrons in its outer shell, carbon has 8 electrons, and oxygen also has 8 electrons. Therefore, they share it so that they can try and establish a full outer shell. Therefore, they completely reacted. That means they're stable. 10. Some properties of 4 solids A, B, C, and D are shown in figure 6. The solids in no particular order are copper carbonate, copper oxide, magnesium metal, and sodium hydroxide. Identify solids A, B, C, and D and explain how the information in figure 6 supports the identification of each solid. So let's go this one by one. Let's see A. We know that the color of the solid is black, and black solid remains when it is added in water. The pH is 7, and the observation of the solid in dilute sulfuric acid is that the solid disappears and it forms blue solution. We know that this would be copper oxide. This is because, first of all, we know copper oxide is black, and we know that when it reacts with sulfuric acid, it makes a blue solution but no glass. So B, we know that it is silver, and we knew that few bubbles appear on the surface of the solid, and this is when it's added to water. And also, when it's added to sulfuric acid, we know that there is effervescence, and that solid disappears to form a colorless solution. We know that that is magnesium. The main thing that we made it know that it's magnesium, not only because it's silver colored, it's because of the few bubbles that appear when this effervescence that happened when it's added to water, because magnesium vigorously reacts with water. And also that it gives hydrogen over here when it's reacted with dilute sulfuric acid, and that is the effervescence. So C, we know that it is a white solid, that the solid dissolves and forms a colorless solution when it's in water, has a pH of 13, so it's an alkali, and we know observation when solid is added to dilute sulfuric acid, it disappears and forms colorless solution. So the thing that's going to make us know is that it is an alkali, and the only alkali that we have over here is sodium hydroxide. Because of this hydroxide over here, which is the OH minus, we know that this is an alkali, therefore it has to be C. Now with D, we know it's green, and green solid remains, and also that it's effervescence and it disappears to form a blue solution. Because it's green, we know that this is copper carbonate. And also because copper carbonate is completely insoluble, this is why the green completely remains. So over here, you can screenshot this, and it's basically me explaining exactly what we were just saying over there. Okay, iron objects can corrode when exposed to the atmosphere. Corrosion involves the oxidation of iron. What is meant by oxidation? Oxidation basically just means that it gains oxygen, and reduction just means that it takes away oxygen. Painting iron objects prevents corrosion. explain why painting iron object prevents this corrosion. And this is because the paint acts as kind of a barrier and a shield, and this means that it's able to exclude any air, oxygen, or water that touches it, because these are the products that makes it corrode from the beginning. Of iron objects can be prevented by painting them or electroplating them. State one other way for preventing corrosion on iron objects. This is sacrificial protection. It basically just means that you add a more reactive metal on top of it, and because it's more reactive, it will be the one that actually ends up reacting with air, oxygen, water, so that the one in lower behind is actually protected from any rusting. 12. A substance is heated at a constant rate and its temperature is taken every minute. During this heating, the substance undergo one change of state. So the results are shown in figure 5. Explain the shape of the graph in terms of changes its movement and arrangement of the particle as substance is heated. Over here, you see this B to C. We know that this is the exact area where the state of change is happening. How we know that is because it is flat. And this is because when it's flat, it's because when the particles in a solid, they are actually used for the energy. This is when they're using the energy to break out of the lattice, break their bonds, and to actually change their state. It is always going to stay in the same temperature because they're in that process of changing and this process of actually using the energy that they gained all this time so that I can actually go ahead and break it. So from A to B, you can see that it rises. We know that it is a solid here. This is because solid particles in a solid are in lattice, so they are in a fixed position. So this means they start vibrating even more and more because there's more kinetic energy because of the increase in temperature, so that it goes up until it starts the stage of state. So once it does actually change, so it changed into a liquid, it continues going since the temperature continues going from C to D. The particles in a liquid, they move past each other so that they slide each other. They're a bit more fluid than solids, but this does also mean that particles even move more rapidly now and as temperature increase. So this is over here. This is it explaining it. Question 13. Calcium carbonate decomposes on heating to form calcium oxide and carbon dioxide. Calculate the relative formula mass of calcium carbonate. So how we do this is all we have to do is just add them together, add every single element together, their relative atomic mass. So we can see over here Ca, that is 40. And we have 1 carbon, so we just take 1, so plus 12. And we have 3 oxygens, so we do plus 16, plus 16, plus 16. That is 100. Calculate the atom economy for the formation of calcium oxide in this reaction, and you must show your working out. So how you do atom economy is the product that you want. It's the atomic mass of the product you want divided by the atomic mass of all the reactants. So it's all the reactants. This one is just the one that you want. So we know that the one that we want is over here, it's calcium oxide. So calcium oxide, there is 1 calcium, so it is 40. And we add that by 1 oxygen, 16, so we know that this is 56. So it's just 56, and this is over all the reactants. We only have 1 reactant here, and we already figured out it's 100. So we do over 100. And then we times this by 100, because it is a percent. We know that this is 56%. Question 14. A student carried out an investigation to determine the order of reactivity for 4 metals, W, X, Y, and Z. A piece of metal W was added to the test containing excess dilute hydrochloric acid. This was repeated with 3 other metals, X, Y, and Z, and in each case, the size of each piece of the metal was the same. The student recorded the observation on each reaction for 3 minutes. And this is here, so metal W, the bubbles formed quickly with some metal remaining after 3 minutes. X, a few bubbles were seen to form. The metal looked unchanged, however, after 3 minutes. Y, bubbles formed quickly. After 3 minutes, all the metals had reacted. And Z, bubbles formed very quickly and no metal remaining after 3 minutes. Use the information in figure A to place the metal in order of reactivity from least to most reactive. So with most reactive, it just means the most things that happened, most physical things that happened. So we can see about how many bubbles were formed, how many product is left, and this is where it kind of just remains unchanged. So if you can see over here, we can see The X looked completely unchanged after 3 minutes. So we know that that's first. And if you see the most reactive, we know that it is Z. This is because bubbles formed very quickly and there was no metal at all remaining after 3 minutes. So that means it completely reacted with the hydrochloric acid. So now we just need to see about the difference. So here we can see that bubbles formed quickly in both of them. And this is over here, it says some metal remaining after 3 minutes, but here it says all metals has reacted. So we know it's W, then Y. 2I, the experiment was repeated using excess dilute sulfuric acid in place of dilute hydrochloric acid. When metal Y reacts with dilute sulfuric acid, bubbles form quickly at first, then the reaction stops. Most of the solid metal remains, so explain why the reaction between metal Y and the excess dilute sulfuric acid stopped even though there was solid metal Y left. This is basically because the metal sulfate starts coating the metal. So because it starts coated, it prevents any further reaction of the metal with the acid. 3I, the reaction between metals and dilute ethanoic acid are slower than the reactions between metals and dilute hydrochloric acid. This is because ethanoic acid is a weak acid. What is meant by weak acid? This is another key term that you need to know. Basically means that it's partially ionized, so it partially reacts, and this is because the concentration of the hydrogen ions are H+, is much lower than expected in a weak acid. So when you see acid, you already know it's H+, but because it's weak, it has a low concentration of it. Question 15. A student wanted to find a volume of dilute hydrochloric acid and would react with 25 centimeter cubed of lithium hydroxide solution. They used equipment in figure 7 to carry out a rough titration, then a further 2 accurate titration. What is the name of the indicator that is suitable to use in this titration? We know that it will be C, which is methyl orange. Question 16. Experiment is planned to record the change in pH as a powdered base in the added to 50 centimeter of dilute hydrochloric acid. The method suggested is step 1. Add dilute hydrochloric acid to 50 centimeter cubed mark on a beaker. Then add 1 spatula of the base and stir. Measure the pH of the mixture and repeat step 2 and 3 until the pH stops changing. State how you change the method so the amount of dilute hydrochloric acid and the base can be added more accurately. So here that they did dilute hydrochloric acid, they measured it with a beaker. Instead, we can do a burette. We can also do a pipette, or you can also do a measuring cylinder. These just have higher accuracy, so the numbers, so you know how it's like, it's 10, 5, 0. These are just smaller and more accurate. So the more of these lines there are, the more accurate you can make it. Now with the base, they added it with a spatula. So instead you can use a balance so that you can actually weigh out the amount. So you can say it's like 5 grams instead of just a spatula, because we don't actually know how much that weighs. During the experiment, pH changes from 2 to 10. If phenol clothing indicator was added in the beginning of the experiment, a color change occurs as the base is added. State the color change that occurs. This is colorless. That's how it starts, and then it ends as pink. Very hot pink magenta. Explain in terms of particles present why the pH increased during this experiment. This is because the acid started to react and started to get neutralized with the base, which is OH-. So overall, we know the concentration of H+ falls. It becomes lower while the concentration of OH- increases. And that was the end of the paper. I hope you guys learned something, and I hope this is very helpful. Good luck on your exam tomorrow. If you have any questions, please do let me know. And if you want any of the other predicted papers, we'll be doing predicted paper for paper 2 as well in the next coming weeks. So please subscribe and like, and we'll see you soon. Thank you.